Hello, we're going to talk about 7-2 today, which talks about powers of 10 and scientific notation. Now, we talked about scientific notation last year, and you've probably talked about it in science as well, so hopefully this is pretty familiar to you. We're going to start with powers of 10. And the rules with powers of 10 is that if we have 10 raised to a positive power, we're going to start at 1 and move the decimal point however many places to the right that our exponent says. So in this example here we have 10 to the 4th. So I start at 1, as you can see here, and I go 4 places to the right. So 10 to the 4th would be 10,000. Essentially I add 4 zeros to the 1. And if I have a negative exponent on a 10, again I'm going to start at 1 and I'm going to move however many places the exponent tells me to the left. So here I started at 1 and I went back 6 spots. So you can see that I put in essentially 5 zeros before the 1. So I got 0.000001. So that's the first thing you'll be doing today, is just taking powers of 10 and finding their actual value. So if I have 10 to the negative 6 here, I'm going to start at 1 and I'm going to go back, because it's a negative exponent, I'm going to go to the left 6 spots. Now this is the same as the example in the table, so this one's pretty easy. So I'm going to have a decimal right here, put a 0 before it, and then put zeros in each of my spots. So 10 to the negative 6 is 0.000001. Okay, now if I have a positive exponent, again this is the same as the one in the box here, but I'm again going to start at 1, and since it's a positive exponent I'm going to the right 1, 2, 3, 4 spots and fill in my zeros. So I'd have essentially 10,000 here. I'll write this one over here without all the squiggly marks as well. Okay, and one more example here, 10 to the 9th. So again, positive. I'm going to move it 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill that in with zeros, so essentially I'm adding 9 zeros to the end of my number. And let's write that again with our commas in the right places. There we go. Alright, so that would be how we find the values with powers of 10. Now we can also go the other way. If we have a number, we can write it as a power of 10. And the way that we do that, okay, is to start at the end of the number, or wherever the decimal is, and in this case it's at the end of the number, and count how many spaces that it moved from 1, because remember we start at 1 when we have powers of 10. So it moved, let's see, 1, 2, 3, 4, 5, 6 spots to the right. So this would be 10 to the 6th power, since it moved to the right. Okay, now let's look at the next one here. Now again, I know that my powers of 10 start here at 1. So how much did it move? Well, it moved 1, 2, 3, 4 spots to the left. So this would have to be 10 to the negative 4th power. And one more example here. So here's where the decimal currently is. Here's where it would be with the power of 10. So it moved 1, 2, 3 spots to the right, so that would be 10 to the 3rd. Okay? So if I have a number that's not a power of 10 and I want to write it as a power of 10, that's how I would do that. Now we can also do this with more than just 10. Alright, if I have a number that's multiplied by a power of 10, I can use essentially the same rules, and this table helps me with that. So if the exponent is a positive integer, again, I'm going to move it to the right, but instead of starting at 1 like I was before, I'm going to start at the actual number that I have. So here I have the number 125, so I'm going to start here at the end of 125 and move my decimal spot 5 places to the right. Okay? So then I come up with 12,500,000 as my number. And then if I have a negative exponent, again I'm going to start wherever the decimal is in the number and go that many spots to the left. So I'd start at between the 6 and the 2 here, go back 3 spots, so the value of that number is 0.0362. So let's look at some examples of that here. So this one is a positive exponent, so I know that I'm going to be moving to the right, and I'm going to move 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to fill those in with zeros. So then I get this number. Okay. Get another one here. 467 times 10 to the negative third. Well, the decimal is at the end of the number. Since it's a negative power, I'm moving 3 spots to the left. So that's going to give me 0.467 as the value of that number. Now, this brings us to the next thing, scientific notation. Now, we were essentially using scientific notation in those examples that I just did. The difference with scientific notation is that the first part, this red part here, always has to be a number that is greater than or equal to 1, but also less than 10. That wasn't true on some of the examples I had before. But for it to be in scientific notation, the first number has to be bigger than 1 or equal to 1, but also less than 10. And then your second part is always a power of 10. So what we're going to work on is going back and forth between scientific notation and standard notation. So here I have Saturn, and it has a diameter of about 1.2 times 10 to the 5th kilometers. Its distance from the Sun is about, well, it's a really big number here, 1,427,000,000 kilometers. So the first says, write Saturn's diameter in standard form. Well, the diameter is currently in scientific notation. So I'm going to use the same rules that we just talked about. It's a positive exponent. That means I'm moving the decimal to the right. So I'm going to take the 1.2, and I'm going to move my decimal 5 spots to the right. Fill that in with zeros, and I come up with 120,000 kilometers. So the diameter of Saturn is 120,000 kilometers. Now the next question here says write Saturn's distance from the Sun in scientific notation. Now it gave it to us in standard notation. So what I need to do is, here's where my decimal currently is. Here's where it needs to be for it to be in scientific notation, right? So, in order to move from where it's supposed to be to where it currently is, it had to move 1, 2, 3, 4, 5, 6, 7, 8, 9 spots to the right. So this number in scientific notation would be 1.427 times 10 to the 9th power because it moved to the right. Okay? So that's how I go from standard notation to scientific notation. One more example for you here. Here's Jupiter's diameter in scientific, or it's in standard notation. I want it in scientific notation. Well, again, here's my current decimal. Here's where I want the decimal to be. So, from where I want it to be to where it currently is, it moved 1, 2, 3, 4, 5 spots to the right. So I'd have 1.43 times 10 to the 5th, because it moved to the right, power. So that would be that number in scientific notation. One more here, if I have Jupiter's orbital speed and I want it in standard form. So I have 1.3 times 10 to the 4th, so that means I'm going to take 1.3 and move it 4 spots to the right. So that's going to give me the number 13,000 meters per second for orbital speed. Okay, so that's what 7.2 is all about, powers of 10 and then scientific notation. Let me know tomorrow if you have any questions about any of that.